Next question. A pipe of length L is open at one end and closed at the other end. A loudspeaker is at the open end and emits a sound wave into the pipe. When a stationary wave is formed, there is an antinode at the open end of the pipe. Which wavelength of sound could be used to produce a stationary wave? Now I flip the picture of this question to compare with the picture of the first question that I solved in this video. The main difference between both pictures is that this one, the air column is determined by the level of water. And in this case, the air column will not change in this pipe because it's sealed right here. So what they have in common? So the opening here is an antinode, just like we have an antinode right here at the opening of this tube. So then we have a node that where the air ends. So right here is a node. And here where the air ends is at the bottom of this tube. So we have also a node. So node and node. Okay, so the problem says that a stationary wave is formed and there is an antinode at the open end of this pipe. So initially I'm going to work with what the question has provided. So if this is a antinode and this is a node, I'm going to connect like this so that the wave is coming, hit the bottom of this pipe, and is going to be reflected. Let me do like something like this, forming that U shape. So here we have an antinode, and here we have a node. Now looking at the picture, we can ask, what is a portion of a wavelength that fits in this pipe? The answer is a quarter of a wavelength. So in this length L, we can fit a quarter of a wavelength. So which means the wavelength is equal to 4 times this length. However, there is no option here that matches with this answer. So the question just says that a stationary wave is formed. So if a quarter of a wavelength is not an option here, next one we are going to try to fit a 3/4 of a wavelength. Okay, so I'm going to erase this and fit here the node also stay here, and this is the antinode, and I'm going to place another node right here. So between two nodes there is an antinode, and this will be a quarter, shorter than before. Then I'm going to erase this because it has changed. Okay, now I need to rewrite this. In this length L, I can fit 3/4 of a wavelength. Some students are a little bit confused about how this is 3/4. So I'm going to write in a different way that will make more sense to you. So if this is a quarter, so between two nodes I have half of a wavelength, which means this is also a quarter. So I have 1/4 here, 1/4 here, and 1/4 here. So I have a quarter, which is this, plus this quarter right here, plus this quarter, and this is, when you add 1, 2, 3, 3/4 of a wavelength. Okay, so now I multiply both terms by 4, right? So I have, actually I'm gonna flip this. I'm gonna do 3 lambda is equal 4L. because I want to arrange this equation in terms of the wavelength or lambda. So this is lambda is 4L over 3. And we have a winner, option C.